Alright, in this video we're going to talk about something called combining like terms. Combining like terms is going to be the foundation for taking all of those constants and coefficients and variables and combining them together so that we can take these really long expressions and make them as small as possible. So what are like terms? So like terms have two important characteristics. For one, they have the same variable and the same exponent, and I'm going to show you what that looks like. The other thing that's important to know is that the coefficients, which means the number that's in front of the variable, those can be different. But again, they need to have the same variable and the same exponent. So some examples of like terms would be 5x squared and 7x squared. They have the same variable, the same exponent, but the coefficients are different, okay? And then I'll show you how to combine those. Another example would be y and 9y. They have the same variable, they have the same exponent, which is 1 because it's invisible, and they have different coefficients. There's an invisible 1 here, and there's a 9 here. And then lastly, another example would be 20w to the 7th power and 2w to the 7th power. They have the same variable, they have the same exponent, but the coefficients are different. The coefficients can be the same as well, okay, but they can also be different. Some non-examples would be 5x squared and 4x to the 3rd. Yes, the variables are the same, but the exponents are different here. And so they are not like terms. Another non-example would be, oops, that's supposed to be a y, y to the 2nd power and y to the 4th power. Again, the exponents are different here, and so those are not like terms. Another example would be 17w to the 4th power and 9x to the 4th power. So here we have the same exponent, but our variables are different, and so that would not work as well. Alright, so let's do a quick check. Are these like or unlike? So here we have 4x and negative 10x. Same exponent, and they both have same variable, and they both have an exponent of 1. So these are like terms. Here we have 6p and 5p to the 4th. This p has an exponent of 1. This p has an exponent of 4. So these are unlike terms. Remember that the coefficient, the number in the front, can be the same, but the exponents, let me rephrase that. The coefficients, the number in the front, can be different, but the exponents have to be the same. I'm sorry, I mixed that up. All right, here we have negative 12y to the 3rd and negative 12x to the 3rd. So our variables here are different, and that's a deal breaker. So these are unlike terms. Here we have 15x squared and 17x squared. So we have x and x, squared and squared. 15 and 17 can be different because the coefficients can be different. So these are like terms. Now, this one is a big boy, but don't let it scare you, okay? What we have to make sure is that all of the variables are the same and all of the exponents are the same. So we have w4 x2 y7. w4 x3 y7. I found the problem right here. Here we have x to the 2nd power, and here we have x to the 3rd power. So these are unlike terms. If this was an x to the 2nd power, these would be like terms. Okay, so let's do a quick exercise. We have done something similar to this before where we're going to break this apart, and then I'm going to show you how to actually combine them. So what are our terms? Remember that our terms are each individual units, and if there's a negative sign, or a minus sign, which is also a negative sign, we take the sign in front of it as well. And so I'm going to sort of start to box these off into our terms. So our terms are 6x, negative 2y, x, and negative 5. Okay, what are our like terms? Well, here's a 6x and here's an x. And then we don't have any other matches because there's nothing that matches with the y, there's nothing that matches with the negative 5. Okay, what are our variables? Well, we have an x and we have a y. What are our coefficients? Well, here's a 6, here's a negative 2, and then there's an invisible 1 in front of there. Okay, and then what are our constants? We only have 1, and we need to take the sign in front of it, and it's a negative 5. This is just to exercise our brain a little bit. Okay, what are our terms? Again, I'm going to box them off so that we can see them clearly. When there's a negative sign in front of it, we need to take the negative sign with it. You always take the sign in front of it with it. So here we have a 13m, we have a 4, we have a negative 6m, and we have a 10. What are our like terms? We have a 13m, and we have a negative 6m. I'm going to draw a line here. And we have a 4 and a 10 that match. They have the same variable, which is nothing, and they have the same exponent, which is nothing. Okay? What are our variables? Well, we just have one. It's an m. What are our coefficients? We have a 13, and we have a negative 6. And what are our constants? We have a positive 4, and we have a positive 10. All right. Now, how do you combine like terms? Very simply here. So, first you find your like terms. Here we have in this problem 3y plus 4y. Well, 3y and 4y are like terms. They have the same variable and they have the same exponent. If they have the same variable and the same exponent, you're going to only look at the coefficient, which is 3 and 4, and you're going to follow what the operation says, which is addition, and you're going to add them together. 7y. You're going to keep the variable and keep the exponent, which in this case is 1, and that is your final answer. It does get more complicated than that, though, so let's keep going. Here we have 14m minus 8m. We have m to the first power, m to the first power, so these are like terms. So all I'm going to do is look at the coefficient, which is 14 and 8, and follow the operation, which is minus. 14 minus 8 is 6, and then I'm going to keep the same variable and exponent, which is m to the first power. All right, let's get a little bit more complicated here. 7k minus k plus 2k. Now in this case, I have k to the first, k to the first, and k to the first. So these are all like terms with each other. That's not always going to happen, okay? Order of operations still applies here. I need to take them in order from left to right because this is all addition and subtraction. So I'm going to look at the coefficients. Here I have a 7. And here, if you remember, I have an invisible number 1, okay? And my operation is subtraction. So 7 minus 1 is going to be 6k, and I'm going to rewrite the rest of the problem. Then I have 6k plus 2k. I'm going to add it together, and I'm going to get 8k. Let's try the next one. I have a to the first power, a to the first power, a to the first power, and a to the first power. So these are all like terms with each other. I have subtraction, addition, and subtraction. I need to follow order of operations and start from the left and work my way to the right. So I'm only going to look at the coefficients here now. I have 14 minus 6. 14 minus 6 is 8a, and I'm going to rewrite the rest of the problem. Okay, now I'm going to take my next set of coefficients. 8 plus 2, that's 10a minus 11a. All right, 10a minus 11a is negative 1a is an acceptable answer, but the cleaner answer is that 1 should be negative. The cleaner way to write it is negative a. All right, next one. I have h to the first power, h to the first power, g to the first power, and g to the first power. So I have different sets of like terms here. So I need to watch what I'm combining, okay? Now, I have, let's take care of the h's first here. Okay, so I'm going to go ahead and just look at my coefficients. I have 4 plus 6, that's going to be 10h. And then I'm going to go ahead and take care of my g's here. I have 12 minus 2, and that's going to be 10g. Okay, that 10g is positive. Now, with combining like terms, when you have multiple variables in your final answer, the proper way to write it is in alphabetical order. Now there's another part of that, which I'll show you when we have exponents here in a minute, but the proper way to write it is in alphabetical order. So what comes first, h or g? G comes first, so this 10g is positive, so 10g, and then the 10h is positive, so plus 10h. Alright, here we have k to the first power, a to the first power, k to the first power, and a to the first power. So let's do my k's first here. So I have positive 5k, and then I have negative 1k, because there's a negative 1 there. So what's 5 minus 1? That's going to be positive 4k. And then I have here negative 20a minus 6a. Okay, this is where you have to start being careful. So you have negative 20 minus 6. Do a keep change if you need to. That's going to be negative 20 plus negative 6, which is going to be negative 26. So that's going to be negative 26a. Okay, now make sure you put them in alphabetical order. Negative 26a plus 4k. That's going to be your final answer. Alright, now we have some bigger exponents here. So we have 5d to the third power plus 5d to the third power. So our d to the third power and d to the third power are the same. So all I need to do now is look at my coefficients. My operation is addition. Okay, so this is going to be 10d to the third power. Alright, let's take a look at the next one. I have x to the second power, m to the first power, and x to the second power. So let me take care of my x to the second power first. So I have positive 8x to the second power minus 3x to the second power. So 8 minus 3 is 5x to the second power. And then my 9m doesn't have a match. So then I just have 9m. Now this is where the extra layer of ordering comes into play. So I told you to order in alphabetical order by variable, but then I told you that there was an extra step. So the way that it works when you have exponents of a higher power is that you need to do your exponents in alphabetical order by power from highest to lowest, okay? So if you were to have, for example, and I'm going to make up a problem here, 5x to the fourth power plus 4y to the third power plus 3a to the second power. So my exponents here are not in alphabetical order, but they're in descending order by exponential power, okay? Then when you get down to an exponent of 1, then you need to go ahead and put them in alphabetical order. And that's going to take some practice, okay? You're not going to be able to do that overnight. So the correct order for this one is going to be 5x to the second power because it has a higher power than 1 plus 9m. And some of you may be thinking, well, how do I know if it's plus or minus? Well, is the 9m positive or negative? It's positive. When you did 8 minus 3, did you get positive 5 or negative 5? Positive 5. Let's take a look at this one. So you have 9r to the first minus 2r to the fourth minus 7r to the first. So here we have 9r, and then here we have minus 7r. So 9 minus 7 is going to be 2r, and then I have a minus 2r to the 4th, who cannot combine with anybody. So I need to put them in order for my final answer. He has a higher power, so he needs to go first. Negative 2r to the 4th, he's positive, so it's going to be plus 2r. And that's my final answer. Alright, let's try here. So it looks like I have n to the first, n to the first. I have a constant by itself, and then I have n to the first. If you have a constant by itself, it's going to go at the end because it doesn't have a variable or a power with it. Okay? So I have 3 minus 2, and that's going to be 1n, and we can just write n. If it makes you feel better to write the 1 in front of it, that's fine. I'm going to rewrite the rest of the problem. So then I have 1n minus 1n. Well, 1 minus 1 is 0, so I'm just left with 5 for this problem. Alright, here are 3 problems for you to try. Make sure you put them in the correct order. Alright, if you're not done, go ahead and hit pause. If you are done, let's go over it. So for the first one, you combine the negative 13p to the third and then the negative 9p to the third, and you should have gotten negative 22p to the third plus 12 minus 1 is 11. For this one here, 1m really minus 9m is negative 8m, but then positive 3 and negative 3 canceled, so you just have negative 8m. Over here, 2r to the 5th plus 2r to the 5th is 4r to the 5th, and then 10 minus 7 is 3, so 4r to the 5th plus 3. Alright, that's the end of this lesson. We're going to spend a couple days on this in class, though, so you will get lots and lots of practice in class, but feel free to ask me any questions that you have.